Data structures are abstract tools used to store and manipulate data in a computer's memory. They allow us to store data in other arrangements and not the cell-by-cell arrangement provided by a computer's main memory, making it a lot easier to retrieve and modify. Think of it like this. The computer's memory consists of a series of cells with unique addresses called memory locations. In order to store the name Victor in the main memory, we will need to put the first letter V in memory location 1x. Then put each consecutive letter in the next memory location until each letter of the name is stored. Thinking of data storage in a computer this way is inconvenient because it is very tedious. Keeping track of where each letter is in memory is difficult and impossible for larger applications with lots of data. However, using a primitive data structure called a string, we can store the name without thinking of how the computer handles it. Data structures like stacks, trees, queues, and arrays give us ways to store other types of data, for example lists, in a way that makes it easy to retrieve and manipulate. Data structures are divided into primitive and non-primitive data structures. Primitive data structures are data structures that are built into computer programs. They can be operated on with machine-level instructions. Non-primitive data structures, on the other hand, are data structures that are derived from primitive data structures. They can't be directly manipulated by machine-level instructions. An array is a rectangular block of data whose entries are the same type. For example, the array of alphabets. All the elements in this array are of the same type, and each letter in the array can be accessed using an index. Now let's talk about lists. A list is a collection of data entries that are sequentially arranged. A popular example of a list being a grocery list or a class list. The start of the list is called the head, and the end of the list is called the tail. Stacks and queues are just lists where restrictions are placed on how the elements can be modified. In a stack, entries can only be removed or added to the top. Think of a stack of books on a table. Now let's discuss queues. A queue is a list where new entries can only be added at the tail, and entries can only be removed at the head. Think of a list to buy tickets to a show somewhere. New customers line up at the back, and those who got their tickets leave at the head. Queues are a FIFO structure, that is first one in, first one out. Sticking to the tickets example, the first customer to arrive is the first customer to leave. The data structures we've discussed so far all store data elements in consecutive memory locations. Linked lists defy this convention. On a linked list, data entries can be stored in any memory location as long as you attach the memory address or location of the next data entry in the list. A null pointer is attached to the last entry of the list to mark the end of the linked list.